Hello everyone. In this session, we are going to discuss about page replacement algorithms in operating system. This is one of the most important concepts in operating system. So before discussing the algorithms, if we start discussing our algorithms, let us go through some basic terminologies regarding this. So the concept here is, if a CPU wants to execute a process say P1, then that process P1 must be in the main memory. If it is not there in the main memory, then that process must be loaded from the hard disk to the main memory. So without this concept, without main memory, the CPU cannot execute any process. So if a process wants to get executed, then it should be in the main memory. That is the concept. So consider the scenario. I am having a process P1 and the size of the P1 is very big when compared to the size of the main memory. So I cannot accommodate this process in the main memory. So what can I do in that case? So in this case, what I can do, I can divide the process, or I can partition the process into equal size pages. So the part of the process can be loaded. So which part the CPU wants to execute, that part itself can be loaded into the main memory. So that is called demand paging. So paging is different from swapping. Swapping is nothing but loading the entire process into the main memory. But paging is the process of loading a part of the program or part of the process into the main memory. That is paging. So now let us take, I am facing a scenario, I am facing a case that the main memory doesn't have any space. It is fully occupied. So actually the main memory is divided into equal size partition called frames. So let us take my main memory can accommodate 3 frames. So in this case, all the 3 frames are occupied. Let us assume all the 3 frames are occupied. So if the CPU wants to execute a process, say for example page 3. So page 3 is not in the main memory, so it has to be loaded into the main memory, but there is no free frames available in the main memory. So in this case, we have to free some space for the fresh page, new page. So what we can do? We can swap out a page from the main memory and you can swap in the page, the required page. So this swapping out and swapping in, these two processes are repeatedly be happening. Okay, so this will be decided by page replacement algorithms. So the page replacement algorithms deals with which pages need to be swapped out and which are the ones that need to be swapped in the memory, into the main memory. So as far as the page replacement algorithms are concerned, the main goal is to reduce the number of page faults. So let us take what is page fault. If the required page is not in the main memory, then it is said to be page fault. So that page has to be loaded from the disk to the main memory. So this is called page fault. So page replacement algorithm should work to decrease the number of page faults. This is what the page replacement algorithm is. So it's a basic procedure followed here. Now for page replacement, we have to find the location of the desired page on the disk. Now to accommodate this disk, you have to find a free frame in the main memory. So if there is a free frame, then you can utilize it. If there is not available, if there is no free frame available in the main memory, then you have to use any one of the page replacement algorithms to choose the victim frame. That is the frame which has to be swapped out. Okay. So after choosing this victim frame, we can bring the desired page into the free frame and update the page and frame tables and everything. So this is what the basic procedure. Now let us move on to the page replacement algorithms. We are going to discuss only 2 page replacement algorithms in this video. So for checking this page replacement algorithms, we are going to take a reference string. So reference string is nothing but it's a collection of some reference page numbers. This is not the memory address, just it is the page numbers. So we are going to evaluate each and every page replacement algorithm by running this reference string. Okay. So the reference string is nothing but this is a sequence of page numbers to be executed. Okay. So let us take this as the reference string. Now let us move on to the page replacement algorithm. We are going to discuss about the first one. First in, first out page replacement algorithm. So how does this algorithm works? See, let us take, this is the reference string 7, 0, 1, 2, 0, 3, 0, so on. So, and as per our assumption, the main memory contains only 3 frames. So, it can accommodate only 3 pages. At a time, the main memory can accommodate 3 pages. Right? So, now this is a reference string. First, when you refer the string 7, page number 7, so you will be referring the main memory. So, in the main memory, initially we are assuming that there are no pages in the frames. All the frames are free in the main memory. So, we can accommodate 7, page number 7 in one of the frames. So, we can accommodate here. And the next page is 0. So, here still we find another 3 frames. So, we can accommodate. And next will be see 1, page number 1. So still you have some free space, so you can accommodate this one here. So now all the frames are occupied now. So when you refer the page 2, now CPU wants to execute the page 2. So now page 2 is not in the main memory. Right? So this is one of the page faults. So initially 7 is not in the main memory, so that one page fault, and 0 was not in the main memory, so page fault, and 1 was also not in the memory, so page fault. Now 2 is also not in the main memory, so this is also a page fault. Now 2 has to be placed in the main memory, but there is no free frame available in the main memory. So among the 3, one frame has to be swapped out. So we are going to choose which one has to be swapped out. Now this algorithm is first in, first out. So whatever the page which comes first will be swapped out. So here the first page is the 7. 7 has come first. So 7 will be replaced by 2. Now in the place of 7 we will be placing the page 2. And now we will be referring 0. So already 0 is in the main memory, so it is page hit, not page fault. Okay, so it's already in the memory, so leave it. And when you refer 3, then search 3 here. 3 is not in the main memory, and also there is no free frames available in memory. So we have to swap any one of the frames out. So here among 2, 0 and 1, 0 is the earliest one. 0 has come earliest. So 0 will be replaced by this thing. Okay. Now 0 comes. So when 0 comes, what will do? 0 is not in the main memory, so it has to be loaded from the disk, but there is no free frames available in the main memory. So what will you do? You will be choosing the victim page. So here among 2, 3 and 1, 1 has come the earliest, so 1 will be replaced by 0. So this process will continue. Okay. So as far as this string, the number of page faults is 15. Okay. But the first in, first out algorithm is very simple and easy to understand, easy to implement everything, but it is not good all the times. See, it may face a situation called delay days anomaly. So what does it delay days anomaly mean? Let's take, if you add more number of frames, then ultimately your result will be that is number of page faults will get decreased. That is the fact. So if you increase the number of page frames, then automatically the number of page faults will be decreased, because more number of frames are available in the main memory, so you can accommodate more pages, right? So number of page faults will be reduced, but in some situation it will not be the case. If you increase the number of page frames, still the number of page fault will increase. Okay, so this is called delay days anomaly. Consider this string 1, 2, 3, 4, 1, 2, 5, 1, 2, 3, 4, 5. For this string, this delay day anomaly will happen. Okay, analyze this graph. for this graph, when you increase the number of frames, number of page faults will decrease. Actually, this will be the case. But if, say for example, number of frames 1, so number of page fault is 2. When you increase to 2, still it is 12. Then when you increase the page frames to 3, the page fault is 9. So when you increase the page frame as 4, still it will increase the page fault. Number of page fault becomes 10. Right? So it should not be the case. This is what Bilady's anomaly. So in order to discover this Bilady's anomaly, or in order to recover from this Bilady's anomaly, we can go for another algorithm called optimal page replacement algorithm. Okay, so here the victim frame will be chosen based on the concept called replace page that will not be used for longest period of time. So I have no, that is, I am not going to use this particular page for a very long period of time, so you can replace it. That is the meaning for this algorithm, this concept. That is, for example, page number 2, I will not be using the page number 2 in future. For a very long period, I will not be using this page. Then you can replace that page, because page fault will not occur, right? So this is the concept used in optimal algorithm. Let us consider the string, the same reference string 701203 and so on. Here the number of page frames are 3. So first 7, it is not in the main memory, so page fault, right? So 7 will be occupied in any one of the frames. Then 0, it is not in main memory. Again page fault occurs. Then 0 will be occupied in one of the 3 frames. Then 1, it is not in the main memory, so page fault occurs. Then you will be keeping the 1. You are having some space in the main memory to occupy with these. Now 2 comes. So when the page number 2 comes, what we can do? See here, 2 is not in the main memory, but there is no space in the main memory. So one among these 3 frames has to be free. So which you can fix. So 701. So see in the right side. So 7. So when I will be using the page 7 again in future. So here in this place only I will be using the page number 7. And see page 0. So 0, and in the next attempt I will be using the page 0, right? And for 1 I will be using here. So among these 3, the 7 will not be used for a very longest period of time. So until this place, 7 will not be used. So I can replace 7. Right? So 7 can be replaced by 2. Okay. So now the frames contains 2, 0, 1. Now 0 comes. So 0 already it is in the main memory. So page hit. There is no page fault. Then 3, page number 3, it is not in the main memory, so page fault occurs. Now 3 has to be loaded into the main memory, but there is no space in the main memory, so one among the frames has to be freed. So which I can choose among 2, 0 and 1. See, 2, 0 and 2 here I will be using, and 0 after 2 only I will be using 0, and after that only I will be using 1. So 1 I will be using last. So 1 will be replaced by 3. Right? So this is how the optimal algorithm works. But the optimal algorithm will reduce the number of page faults. Still, it is very difficult to implement because we should know the future knowledge, right? So it will not be the case in most of the cases. So it is very difficult to implement. That's the thing. So among these 2 algorithms, in FIFO, we'll be facing Bilady's anomaly. It's very simple but not always good. The optimal, it is very hard to implement but it is very effective. It will reduce the number of page faults. Okay. So in this case, for this reference string, number of page fault is 1, 2, 3, 4, 6, 8, 9. And in FIFO, 15 page faults. Right? Thank you.